right, class, we are going to start section 5.1 today. Chapter 5 is all about logarithmic and exponential functions and the transcendental functions. So there are going to be a lot of formulas in this chapter. So you want to be able to keep up and memorize those formulas as we go through them. Section 5.1 is just on the logarithmic function. And actually, we're just going to look at natural log today. So y equals the natural log of x. You should be very familiar with this parent function graph. It goes to the point 1, 0. It approaches the y-axis on the left, and it goes to infinity on the right. So the domain of the natural log function are the values x greater than 0. The range are all reals. So all the y values from negative infinity to positive infinity. So natural log of 1 equals 0. Very important for you to remember. The base of your natural log function is e. So e is just understood to be there. You do not have to write it. Hopefully everybody remembers their log rules. By your log rules, I mean that if you have natural log of a times b, that is the same thing as natural log of a plus the natural log of b. For example, if I have natural log of x times cosine x, I could write that as natural log of x plus natural log of cosine x. If I have natural log of a divided by b, that log rule is natural log of a minus natural log of b. So if my problem is natural log of x divided by let's make that cosine x on the top, on the numerator. So cosine x here divided by x, we could expand that and write it as natural log of cosine x minus natural log of x. Another rule, or the last rule we're going to talk about, is if it's natural log of something raised to an exponent. That exponent can be brought down front. Now look, this is just a raised to the n. It's not the natural log raised to a power. And we can bring the natural log down front. So if you have the square root of anything, so natural log square root of x squared plus 4, that can be rewritten as 1/2 natural log of x squared plus 4. Okay, so you will use those logarithmic rules throughout this whole chapter. So let's look at an example. Let's say our problem is the natural log of x squared plus 3 quantity squared over x times the cubed root of x squared plus 1. So that's natural log of this whole quantity. We want to expand it. This is written as one natural log problem. We want to write it as many natural log problems. So if I expand it, it is going to be equal to 2 times the natural log of x squared plus 3, because I bring this exponent down in front. Then I say minus the natural log of x minus 1/3 natural log of x squared minus 1. These are minus signs. You subtract them because of your division logarithmic rule. Now, the reason why you want to be able to expand these is because of the derivative rule. The derivative of the natural log of u is equal to u prime over u. U prime over u. So if we look at this original problem that we just expanded, if I asked you to take the derivative of that big quantity, you would be doing the quotient rule, the product rule, and the chain rule all in one problem. However, if you do it in expanded form, you're going to take the derivative of 3 separate natural log problems. So, let's say our function is y equals the natural log of x squared plus 3 quantity squared over x times the cubed root of x squared plus 1. Your directions. Find the first derivative. And just because this is a natural log problem doesn't mean the derivative has changed its definition. We are still going to use the derivative to find the slope at a point. So, before I find the derivative, I want to write it in expanded form first. So we've already done that. So I'm going to write my expanded form, 2 natural log of x squared plus 3 minus the natural log of x minus 1/3 times the natural log of x squared minus 1. So my derivative, because my rule is u prime over u, the derivative of x squared plus 3 is 2x. I already have the 2 in the front. It's my coefficient. Derivative of x squared plus 3 is 2x over x squared plus 3. Minus 1 over x minus 2x over 3 times x squared minus 1. I am going to simplify that a little bit. I'll write it as 4x over x squared plus 3 minus 1 over x minus 2x over 3 times x squared minus 1. And that is the first derivative. Of course, you will use this, the first derivative, to find where a function is increasing, decreasing, and its critical points. So, if my function is y equals natural log of x squared plus 2x plus 3, I want you to find or locate the relative extrema. Well, we know the relative extrema comes from the first derivative, or our critical points. So I have to find the first derivative. It's a natural log problem. So the derivative of x squared plus 2x plus 3 is 2x plus 2 over x squared plus 2x plus 3. That's my derivative. I set that equal to 0. The numerator is equal to 0 at -1. My denominator, which will make the derivative undefined but is still a critical point, is equal to 0 at x plus 3. Oh, that doesn't factor. So it's never equal to 0. So I want to put -1 on my first derivative number line, which I have labeled. If I plug in -2, I will get a negative number. If I plug in positive or just 0, I will get a positive number. So that means my graph is decreasing, then increasing. So x equals -1. is a relative minimum? We could look at the graph if we wanted to and make sure that it works. Okay, so for next class, I want you to try a couple problems, just finding the derivative. So on page 330, I would like for you to try number 49 and 51. Good luck.